We are moving to sections P2 and P3 today, which is a little bit of review. Exponents and scientific notation are in this section, but I'm not going to explicitly go over them in class. There's things that you should have seen before, and you can just take a quick peruse through the book to make sure that you remember how to do that. What we're going to talk about mostly today is radicals and rational exponents. So radicals, we're going to think about a geometric interpretation of the square root. So the concept of a square root, so suppose that this square has an area of 25 square units. Okay. Then that means that the length of each side has to be 5, right? Because 5 squared is 25. So this is the equivalent of asking, what is the radical 25 or radical 5 squared? In both cases, the answer is 5. 5 units is in the geometric problem and 5 in the algebraic problem. So the radical symbol is that thing that kind of looks like your old division sign, but with a little check mark on the front. It's used to denote only the non-negative square root of a number, also sometimes called the principal square root. So in general, all positive numbers have what kind of square roots? Positive or negative? Positive. If you have a positive number, they have, oh, sorry, 2 square roots. In general, all positive numbers have 2 square roots. 2 numbers that when you square them, you get the number. So think of 25. What number can you square to get 25? 5. What other number can you square to get 25? Negative 5. Why negative 5? Somebody explain. Yes, because negative 5 times negative 5 is positive 25. So there are 2 numbers that you can square to get 25. 5, because 5 times 5 is 25, and negative 5, because negative 5 times negative 5 is also 25. So in general, all positive numbers have 2 square roots. One of them is positive, and one of them is negative. Okay. Like for 25, we have 5 and negative 5. The square root of 0 is 0, so there's only one square root, and it's neither positive nor negative. So when I write the square root symbol, I'm using that to ask you for the positive square root. Okay, so in general, every number has 2 square roots, but that radical sign is a symbol that means the positive square root. So I would write that the square root of 25 is what? 5. Yeah, good. So to denote the negative square root, you put a negative sign in front of the radical. Okay. So I would write the negative the square root of 25 is negative 5. Okay, so square root vocabulary also includes terms like radicand, index, and radical sign. So the x is the radicand, the number under the square root sign. N is called the index, the nth root, the root that we're looking for, it's called the index. And the root we are trying to find, which is what we're trying to find, and the square and that symbol is the radical sign. All right, so let's do a few examples. I want to find the square roots of these numbers. So my number is 144. What is radical 144? 12. And what is negative radical 144? Negative 12. And the way that we combine these into one single notation, because mathematicians are very efficient, instead of writing positive 12 or negative 12, we write plus or minus 12. Okay. All right, I would like for you guys to work through and discuss the next 3. Okay, so let's go through this. What's the square root, the positive square root of 16/25? 4/5, very good. So you all remembered that when you take the square root of a fraction, you take the square root of both the top and the bottom. All right, what's the negative square root of 16/25? Negative 4/5. And if I was going to write that symbolically, we plus or minus 4/5. All right, how about 7? What's the positive square root of 7? 2.63-ish, yeah. So there actually is no way to simplify the square root of 7 as an exact value. So we could get a decimal approximation, but that decimal goes on forever and ever and ever and never repeats a pattern. So we could write approximately what it is, but if we want to be exact, the best we can do is write square root 7. No, that is an irrational number, so I'm not avoiding it. Yeah. I'm trying to avoid an approximation. Yeah. So this is a good thing to know the distinction. Particularly like in my math lab, if they ask you for an exact answer, you would want to write in square root 7. So if they ask you for to round or to use an approximation, then you can use 2.36 or whatever it was. So here it's going to be negative square root 7 because I'm being exact, and plus or minus square root 7. Okay, negative 49. What number? So I want the square root, right? So that means what number do I square to make negative 49? Well, 7 squared is positive 49. So negative 7, oh wait, negative 7 squared is also positive 49. If you move the negative out of the radical, but that's not what this says. This says, I want the square root of negative 49, right? Which means find a number that when you square it is negative 49. What's I? It is, yeah, but we don't know what that is yet. So pretend you don't know what an imaginary number is. There is no such number then, right? That when you square it, you get a negative. Because when you square something, it always comes out positive, because either if it's a positive number and you square it, it's positive. And if it's a negative number and you square it, it's still positive, because a negative times a negative is positive. So this, we say, is undefined for right now. UND is short for undefined. Okay, so what is the square root of 8 squared? Great. Right, because it just undoes each other. Because you square 8, you get 64, and then you say, okay, what number did I square to get 64? Back to 8. Okay. But what is the square root of negative 8 squared? Nope, it's just 8, yeah. So we can do it in a couple of steps. Do what's under the radical first. What is negative 8 squared? 64. So this is equal to the square root of 64, which is 8. Right? When we do that radical sign, it means the positive square root. Unless I put a negative sign in front, it means the positive square root. So if I do the square root of negative 8 squared, I get positive 8 out.
So you do your regular process. What I would do is just cross out the square root.
Yeah. Yeah, if you do it out, you don't get that. So that's actually why I put this example up here, is because it's very tempting to think that square root and squares cancel each other. And when the number is positive, that's true. But when the number is negative, you get the positive back. So what's the mathematical concept that takes a number and makes it positive no matter what? Absolute value. So what do you think the square root of a squared equals in general, whether a is positive or negative? Sometimes it's a, right? Because if a were 8, you'd get the 8 back. But if a is a negative number, you get a positive back. So if I'm taking the square root of a squared, I might get a back if a is positive. It's the absolute value of a. So you can think of square root and squaring as canceling each other, but you get the absolute value, not a itself. Yeah, so maybe if I do a couple more examples, that might help. So if I do the square root of 5 squared, what do you get? Yep, that's the square root of 25, which is 5. if I do the square root of -5 squared, that's also the square root of 25, right? Which is 5. So in both cases, the square root of 5 squared and the square root of -5 squared, they both give me the absolute value of the number inside. Does that make sense? So whatever number I'm squaring and square rooting, the answer is always going to be the absolute value of that number. So for example, the square root of -6 squared would be the absolute value of -6, which is 6.
You can't just say 6.
Yeah, you can just go 6 if you want. That's fine. You just did the absolute value part in your head. That's all. So let's see if this rule holds for other roots. If I do a cube root of 5 cubed, well, what is 5 cubed? 125. It means 5 times 5 times 5, right? So I want the cube root of 125. What number do you cube to get 125? 5. Okay, so I get the 5 back. Good. Let's see what happens when I have a -5. I want the cube root. What's -5 cubed? -125, because that means -5 times -5 times -5, 3 negatives, so the answer is going to be negative. And then what number do you cube to make -125? -5, right? So I don't have the absolute value thing when the index is odd. When the index is odd, they actually do just cancel each other. Cube rooting a cube, you get the number back. So the cube root of 5 cubed is 5. The cube root of -5 cubed is -5. So when the index is odd, you can just think of them as canceling. So here's another even. The 4th root of 5 to the 4th. So 5 to the 4th, what's that? 625, I think. So I want the 4th root of 625. So what number do you raise to the 4th to get 625? 5. Okay, good. And then the 4th root of -5 to the 4th, that's going to be the 4th root of -5 to the 4th is 625, because -5 times -5 times -5 times -5, that's 4 negatives. They multiply together to make a positive. And what number do you raise to the 4th to get 625? 5. So with the 4th root, we got the absolute value thing. We plugged in a negative and we got the positive out. Okay, so the output's always the absolute value when the index is negative. So here are the big conclusions, some silly phrases to try to help you remember. If n is odd, then the nth root of a to the n is a. We end up where we started. If n is odd, don't modify. If n is even, the nth root of a to the n is the absolute value of a. We end up with a positive number. If n is even, absolute value gets its revenge. Even is in the word revenge. So when n is even, when you take an nth root of raising to the n, you get the positive number back. Any questions on that? A little tricky at first. Okay. So we want to find the value of each of these radicals. The square root of 9 times 4. So in this case, the square root is over the whole thing, so I'm going to do the multiplication first. So what is 9 times 4? 36. This is the square root of 36, which equals 6. And the square root of 9 times the square root of 4, this time they're separate, so I'm going to do square roots first. Square root of 9 is 3. Square root of 4 is 2. 3 times 2 is 6. Comes out the same. That is generally true. If you want to do the square root of a product, you can break it into the product of 2 different square roots. And you can go the other way. If you have the product of 2 square roots, you can put them together into 1 square root. Do whichever way makes things easier for you. So for example, I want to do the square root of 400. I don't know what the square root of 400 is off the top of my head. So I'm going to break 400 into the product of two numbers I do know the square roots of. The answer is 20. Did you just know the square root of 400 was 20? With the zeros? Okay, so you broke it. You saw that 4, and you said, I know the square root of 4, right? So we said, okay, I'm going to rewrite this as the square root of 4 times 100. So that's what the zeros thing that you were thinking of. And then that's going to be the square root of 4 times the square root of 100. Square root of 4 is 2, square root of 100 is 10, and you get 20. You can also use 25 and 16. Let's see how that works. Right? So the square root of 25 is 5, square root of 16 is 4, 5 times 4 is 20. So you get the same answer. Okay, you try. Square root of 500, no calculator. Square root of 500. Can anybody think of a perfect square that goes into 500? Yeah, 100. That's an easy one, right? So I could write this as the square root of 500 is equal to the square root of 5 times 100. Okay, and then take the square root of each piece. Well, the square root of 100 is 10, right? What's the square root of 5? Square root of 5. There is no nice, pretty number that represents the square root of 5, so we can just leave it. 10 square roots of 5. It's just like the 7, right? We couldn't take the square. You can get an approximation for the square root of 7 or for 5, but the exact value is just written as the square root of 5. Anybody do this one differently? Yeah, what'd you do? Times square root of 20, okay. So square root of 500, rewrite as the square root of 25 times the square root of 20. Square root of 25 is 5. And did you stop here? Okay, and then we can continue simplifying the square root of 20 by writing it as 5 times the square root of 4 times the square root of 5. Rewrite the 20 as 4 times 5. And the square root of 4 is 2. So 5 times 2 is 10 square roots of 5. Same thing we got up there. Good, thanks. All right, let's take a look at part B here. Square root of 6x times the square root of 2x. Well, I've got two square roots multiplied together. I'm allowed to put all of that stuff under a single square root, right? So I'm going to rewrite this as the square root of 6x times 2x, which is the square root of 12x squared. Square root of 12 times, we have an x suggestion, what? Sure, yeah. Something times the square root of 12, right? I want to take the square root of x squared. What is that? Sometimes it's x. Absolute value of x, right. Yeah, this is what we were just talking about. Oh, actually, we can simplify square root 12, can't we? Let's do that. Absolute value of x, square root 12. And then, how do I simplify square root 12? 4 times 3, take the square root of each of those, and I get square root of 4 is 2, and a radical 3. Right, you got to have the absolute value. Yep. Okay, you try with the radical 10x times radical 8x. All right, so I have the product of two square roots. I can write them as a single square root, take the product of the things underneath. So this is equal to the square root of what? 10 times 8 times x, right? Yeah, so I get 80 x squared. Okay. And then I can take the square root of each of those separately. So I get the square root of 80 times the square root of x squared, which is absolute value of x. Good. And then 80, is there any perfect square numbers that divide into 80 evenly? 16, 4, 16. You generally want to find the biggest one, but even if you don't, you're still going to get there. It's just like, you know, not taking the straightest path, but that's okay. Some of us like the scenic route. Okay. So 80 is 16 times what? 5? 16 times 5? So the square root of 16 is 4, and the square root of 5 is the square root of 5. So we have 4 absolute value x times the square root of 5. How is that? Any questions? Okay. All right, what's the square root of 9/4? 3/2. What's the square root of 9 divided by the square root of 4? 3/2. So similar to the multiplication results, when we do division, you can either take the square root of the whole thing, or you can take the square root of the top and the bottom separately. Now it is important to know that when you're taking the square root of a sum or a difference, that cannot be simplified. So the square root of a squared plus b squared is not equal to a plus b. Square root of a squared minus b squared does not equal a minus b. So for example, right, if I do the square root of 9 plus 16, what is 9 plus 16? 25. So this is the square root of 25, which is 5. Okay. So the square root of 9 plus 16 is 5. If I tried to write it as the square root of 9 plus the square root of 16, that would be 3 plus 4, right? Which is 7, not 5. Right? So this way, right? So this way is wrong. Can't do that. Because the order of operations says you have to do what's grouped together first. Think of that big square root as parentheses. So you can't take the square root before you add them together. So this is a super common mistake in this class. So drill it into your head now. Okay, anybody know what 64 to the 1/2 means? Square root of 64, yeah. So the number on top, when you have a fractional exponent, the number on top is your power, and the number on the bottom is your root. Okay? And the way you can remember that is that roots go in the cellar. Right? If you live on a farm, you know what I'm talking about. So roots go in the cellar. So 64 to the 1/2 means 64 to the first, right? So my exponent is the 1, and my root is a 2. So it's the square root of 64. And when I don't put an index here, we assume it's a 2. What about 64 to the 1/3? What would that mean? The cube root of 64. So my power is 1, 64 to the first, right? And I have a cube root, which is just the cube root of 64. Because raising something to the first power is just the thing itself. So the square root of 64, that's 8 cube root of 64? 4, I think. Yeah. So in general, a to the 1 over n is the nth root of a. So 8 to the 2/3, using the same trick, power on top, root on the bottom. 8 to the 2/3 means 8 squared, cube rooted. Or the cube root of 8 squared. The order of the two exponents doesn't matter. So I can either square the 8 and get 64, cube root it and get 4, right? So this would be the cube root of 64, which is 4. Or I can take the cube root of 8, which is what? 2, and 2 squared is 4. So you get the same thing either way. So this is something that's really going to help you on, say, a non-calculator quiz. Knowing that you can do that in either order really helps you do stuff in your head, because you can do one of the orders is often easier. In this case, they were both sort of equally easy. All right, how about 8 to the negative 2/3? What should I do there? How did you get the negative 64? Okay, so my power is a negative 2. All right, so I'm just going to back up one step to before what you did in your head. Okay, so 8 to the negative 2/3, you said it's the cube root of negative 64, and the way you got that is you said, well, it's 8 to the negative 2, right? Is that what you pictured in your head? Okay. All right, what is 8 to the negative 2? Yeah. Close. Close. Not the square root of, but...
Oh, sorry, the square.
The square. 1 over 8 squared. So remember, negative exponents move the number from one part of the fraction to the other. So this is the cube root of 1 over 8 to the positive 2. So raising numbers to negative exponents, flip them. Okay. And so this is the cube root of 1 over 64 as opposed to negative 64, which is, this is another really common mistake. It's when you deal with negative exponents. They make fractions. So the cube root of 1/64, what do you think? 1/4. Very good. Okay, so in general, a to the m over n is going to be a to the m. Oops. To the m power and the nth root. Or the nth root and then raised to the m. You can do the order in either way. Okay, so before we move on, I just want to show you that your calculator can do all these things. Radicals and rational exponents. So if I wanted to do 8 to the negative 2/3, I would press 8. And then this little caret button is the raise to the button. So you press the little caret. And then I want to raise it to the negative 2/3, and I have to put parentheses around that to mean that whole thing is in the exponent. And when you hit enter, you get 0.25, which is the same thing that we got, 1/4. Okay. If you want to do an nth root, like the cube root, like let's say I want to do the cube root of 1 over 64. Maybe you got this far by hand and you can't figure out the cube root of a 64th. The cube root button is in the math menu. 3 buttons down on the left, you press math. Go down to option number 4, cube root. And then we could type 1 divided by 64, close the parentheses, and we get a 4th. If you want any other root other than the square or the cube, you put it in first. So let's say I want to take the 4th root of 64. So you tip 4 first, because I want the fourth root. Then you go to the math button and choose option 5, which is the xth root, right? And we already put in the 4. So now it knows that it's going to take the fourth root. And I put in a 64. And I guess the fourth root of 64 is 2.82. Okay? All right, so let's do some of these together. Oh yeah, there's a there's a typo in the solutions on number 12. C should be 5x cubed y squared. So why don't you guys take a few minutes at your seats to work through A, B, and C. The answers are there, so you can check them. Okay, so 12A. The answer I had was correct because this is all multiplication, so I can do it in any order. So I can do the 3 times the 4, and I get 12. And then you have times x to the 2/3 times x to the 3/4, right? And then when you multiply like bases, you add the exponents. So what you guys had showed me before was multiplying the exponents, which is not right. Add the exponents. So this ends up being 12 times x to the 2/3 plus 3/4, right? So this is 12x, and then I have to add those two fractions, and if I do it in my head, let's see, that would be 8/12 plus 9/12, which is 17/12. There we go. Good. So 2/3, I'm doing 2/3 plus 3/4, right? Multiply this by 4/4 and this by 3/3, 8/12 plus 9/12. Thanks. Okay, thank you for fixing all of our mistakes.